Alright, we're back. Now we need to implement something because you see here right now. Oh, wait, that's not good. Um, okay, look at that, it works. I'm not sure how, but if I made a lag machine, right, and slowed the tick cycles down, this would slow down because what's happening is this computation here, checking for key press, it's happening once each frame. What happens if a frame takes really long? Um, it would slow down, and that's not good. You don't want to be running and then in a game, right? But then if you have a really fast computer, you would be running at an unplayable speed. If you had a really slow computer, same would happen. You'd be an unplayably slow speed. Um, let's just see. What if I have a NumPy calc that takes a long time? Wait a minute. All I have to do really here, mm, I can just change the frames a second to 30. Okay, and look at that. It's noticeably slow. It's half the speed. Unacceptable, right? What we need is a delta variable. So up here, we also want to import time. Wait, hold up. Pygame. Does Pygame handle delta? Delta. Okay, clock. Okay, this should be delta time. Delta time in milliseconds. Okay, so then we need to just. Okay, delta time seconds should be dt over 1000. Every frame, the time it takes should be. It should wait. Limit FPS to 60 FPS and return the delta time. Clock dot tick, which is an SDL delay, less accurate but uses CPU or clock tick busy loop, which is more accurate. Less CPU. Busy loop. Okay. So it's not the like high accuracy, but we don't need that high accuracy. We just need it to not be noticeable. Mm. Okay, so now. Oh god, where's DTS? Delta time seconds. Okay, now while running. Okay, so first thing we do is just do that. And it will get an error because DT hasn't been set. DT, we'll just set it to that. Okay, because it is a float variable, value. Okay, so now, instead of doing it, instead of defining our speed here, right? Um, player direction, okay. Player direction equals angle to vector. Angle to vector, okay. Okay. here's where we're changing it. Um, hold on, let me think. So in before we were defining it in like degrees per frame. Now we need to do degrees per second. So we time this by delta times seconds, and we use seconds because it's easy, like meters per second. Okay. So now we should have it even slower. Yeah, look how slow that moves. So it only moves 1 degree in a second, but now we have like a lot more variation in our values, which is not necessarily better. But now this should be consistent. So let's say, let's just add in, we imported time. So let's bring our frame rate down to 1 FPS, right? 10 FPS. And now look, even though we're ticking 10, we're still going faster, and let's bring it all the way down to 1. The update, it's it's skipping forward, but look at that. It's still moving at the same speed. We can set up to 200. That actually seems slower. Oh, because it's not. Does this not have delta? Milliseconds per frame. Sleep. Start plus milliseconds per frame. Last time. Okay, now this is separating rendering from game ticks, which is interesting. Current time, elapsed, current time, minus previous time. Previous, now we set that to current. Lag plus equals elapsed. Process input. While lag, we update. So while we still have extra time, we're updating the game and then rendering it. But we don't always render. Mm, yeah, we don't need to go this far. Oh, engine. Okay, well, what it's seeming like is that, like it looks fine. Okay, that feels sluggish. No, that also feels sluggish. I think it should be being the same. Okay, how about I start a timer? Stopwatch. I'm even streaming. Hello.